Hey everyone. So, in computer science, there's this one really fundamental question we're always asking ourselves. Which way of solving a problem is actually better? It's not just about getting an answer, it's about getting it efficiently, especially when you're talking about huge amounts of data. And to do that, you really have to master the skill of comparing functions.
All right, let's jump right in with a classic showdown, n squared versus n cubed. Now, you probably have a gut feeling about which one grows faster, but how do you actually prove it? How can you be totally sure which one is going to eat up more resources as n gets bigger and bigger and bigger?
Well, that's exactly what we're going to tackle today. And I promise, by the end of this, you are going to have two really solid methods in your toolkit to compare pretty much any two functions and know without a doubt which one comes out on top. So our first method, it's probably what you do right off the bat. It's super intuitive. We're going to call it the spot check. Just think of it as the quick and dirty, common sense way to get a feel for how these functions are behaving. The idea here is really simple. You just plug in a few numbers for n and see what happens. So if you look at the table, when n is 2, n cubed is already bigger. Okay. Then when n is 3, whoa, the gap gets way bigger, 9 versus 27. And by the time n is 4, it's not even close, 16 versus 64. The pattern seems pretty obvious, right? N cubed is just taking off. Okay, and this is a big but. Here's the catch. While this spot check is fantastic for getting a quick gut feeling, it's not a formal proof. It's just not. What if things totally change when n gets to be like a million? For an exam or a tech interview, you need something way more solid. This method can sometimes even trick you, so we absolutely need a more powerful tool. So yeah, that spot check method just isn't going to cut it for the big leagues. We need something more powerful. And that brings us to method number 2, the logarithm magnifier. This is the pro technique, the master's approach for getting a definitive mathematical proof no matter how gnarly the functions look. So, logarithms. Why on earth are we bringing them into this? Well, think of them like a mathematical magnifying glass. They have this superpower where they simplify functions. They can take exponents and bring them down to become simple multipliers. They can turn multiplication into addition. They basically strip away all the complexity so we can see what's really going on underneath. Now, to use this awesome new tool, you really only need to remember two key rules for what we're doing today. First, the product rule, which lets you split a log of things being multiplied into two logs being added. And second, the power rule. This one is the real MVP for us. It lets you take an exponent from inside a log and just move it right out front as a multiplier. Let's go back to our first fight, n squared versus n cubed. Let's see what happens when we use our new tool. We take the log of both sides. For n squared, the power rule lets us pull that 2 down, turning it into 2 log n. For n cubed, we pull the 3 down and it becomes 3 log n. And just like that, the comparison is dead simple. Since 3 is obviously bigger than 2, 3 log n is the bigger function. No more guesswork. That's a mathematical proof. Okay, that was the warm-up round. Pretty easy, right? Now let's see where this logarithm magnifier really shines. We're going to throw a much trickier problem at it. All right, check this out. In one corner, we have n squared log n, and in the other, n times log n to the 10th power. Yikes. I mean, just looking at it, it's really hard to tell, isn't it? That power of 10 looks really scary. But then again, n squared is a very powerful term. Trying to spot check this one would be a total nightmare. So let's bring in the magnifier. We'll start with that first function, f of n. First, we take the log of the whole thing. Now, because we have n squared times log n, our product rule lets us split into log of n squared plus log of log n. See that? Then our power rule lets us take that little 2 and bring it out front. So our final simplified version is 2 log n plus log of log n.
Now for function number 2, g of n, we're going to do the exact same thing. We apply the log to the whole expression, the product rule splits it into log n plus log of log n 10, then that trusty power rule lets us bring that 10 down. And there we have it, log n plus 10 log n.
And just like that, here we are, the final face-off. We took those messy, complicated functions and boiled them down to these two much simpler expressions. It's a lot easier to see what's going on now, but we're not quite done. We still need to figure out which part of each expression really matters. Okay, and this is the most important part. When you're comparing these, you only need to look at the fastest growing piece on each side. We call that the dominant term. And let me tell you, the log n term grows way, way faster than the log of log n term. So the real fight here is between 2 log n on the left and just log n on the right.
And since 2 log n is clearly bigger, our first function, f of n, is the winner. It's what we call asymptotically larger. That's just a fancy way of saying it will always be bigger in the long run. So let's wrap all of this up. I want to give you a quick summary you can take with you. Think of this as your cheat sheet for your next exam or any interview question that comes your way on this topic.
So here's the method smackdown. The spot check? Yeah, it's great for a quick, intuitive guess when the stakes are low. But when you need a formal 100% correct answer, the logarithm method is your go-to. It's the one you use for proofs, period.
And here are your key takeaways. Number 1, when in doubt, just apply logarithms. Seriously, it's almost always the right move. Number 2, their whole job is just to make complicated stuff simple. And number 3, the biggest one. After you simplify, always find and compare the dominant terms. That's the part that tells you the real story. Okay, so now you have the tools. You know the techniques. So I'm going to leave you with a final challenge. How would you go about comparing n factorial versus n to the power of n? It's a beast for sure, but with a logarithm magnifier in your back pocket, you now have a clear path to the answer.